Hi everyone, thanks for tuning in. I'm Andrew. I'd like to take a few minutes of your time to tell you a bit about the next generation of battery technology that is heading our way very soon. We're talking here about the kind of batteries that will replace the existing rechargeable lithium-ion batteries that you use in your consumer devices like smartphones, tablets, that kind of stuff. Now, anybody who uses those kind of devices at the moment knows that they have a few inherent problems, and if we could do something to solve those, we'd be a long way down the track to improving the whole experience. One of the main things that that people don't like with the existing technology is the amount of available power coming from the battery, the time that it lasts, the duration, the stamina, the time that it takes to recharge that battery. You would normally expect that you're talking an hour or more to recharge a battery, often giving out at the wrong time entirely. And the number of recharge cycles that you get out of that battery before it cannot be recharged again, typically 300 to 400 cycles. So if you're recharging your battery every day, then it's not going to last you very much more than a year. So seldom will the battery last the duration of the normal lifespan of the product. You will need to replace it at some stage. The other point, of course, is the size and the weight of these batteries, the components within them, the heavy container that keeps all the toxic elements in place. That all takes weight, and as you try to increase the power of these batteries, you also need to increase the size, because they are related. The volume is related to the amount of power that they can generate. So what can we tell you a bit about the most people understand in principle how a battery works. It's an electrochemical reaction going on within a sealed container. There are generally two electrodes in there, the anode and the cathode. In the case of a lithium-ion battery, lithium is a main component. The lithium ions are moving through a medium, through an electrolyte, between the two electrodes, and that chemical reaction causes power to be generated. And the power can be harvested by connecting a load across the two terminals. Now, one of the big issues with the lithium battery at the moment is the anode is constructed from a solid carbon piece. Carbon is not a great conductor. It also doesn't take up the lithium ions as well as it should do. So there is a limit to the amount of power that can be generated using those components. Now, what the new technology has done has looked at those electrodes and said, well, we need a better design. And the design that most of them seem to have come up with is a three-dimensional electrode, which has a massively increased surface area, something like 60 times larger. Is the anode in one of these new batteries to the existing ones, and the layout is really quite different. Some of them are laid out a bit like a sponge. Other ones are really a forest of very thin wires, nano wires, so much thinner than a human hair. Those are made of silicon usually and coated in copper for the conductivity. It can be quite difficult to understand that, but they talk about the two electrodes being interdigitated. So rather than being completely separate, they are kind of interwoven. So the movement of the ions is that much freer than it would be in a conventional battery. And they are seeing much higher power being generated, but there are some other really big benefits coming out of it as well. One of the easiest ways perhaps to understand this is the analogy they use for it is If you imagine a group of people exiting a theatre, in a conventional battery they all exit through a single door, so they're all queuing to try and get out of that same door, so you have a very slow passage of people, or in this case ions. With the new ones, it's like somebody has thrown open exits all around the building, so the theatre goers or the ions are free to move as quickly as they want to. One of the big spin-offs from this is that in the other direction, as the battery is recharging, that recharge reaction is much quicker than it used to be. So the battery can now be recharged in minutes rather than hours. The materials they're making these things out of, they're much lighter, they don't need such a big container, so the batteries are smaller, or alternately you could keep the battery the same size it is at the moment, but because of the increased power you would actually get more power per volume coming out of that. Now the companies that are behind this technology are primarily based in the United States, in universities. They're very well funded generally. They're very good at attracting venture capital. They often have US research grants as well, and they have been very good at spinning off this technology into startup companies with very good intellectual property protection for both the process and the design of the battery. Now, if you'd like to hear a bit more about this, and I think you probably will, get back to me soon. Cheers, bye.